Hey everybody, welcome to Lab 9, the synthesis of cyclohexanone from cyclohexanol. Just so you know that this is an oxidation reaction, and this is the digital version of that oxidation reaction. While you aren't going to be physically handling the chemicals yourself, you will be doing all the thought processes and interpretation that you'd normally be doing in the lab. So let's take a look at what's going on here. So you'll see, again, if you're watching this, that means you're already watching the video explanation. And then in Organic 2, we're going to make sure that you get some really solid foundation on chemical separation principles and lab principles. So we want you to watch this extraction video. This is a video that explains how to do extraction and maybe why it's done. If this doesn't float your boat, you can always watch this video here. This is a video, that's a video of Professor Dave explaining how to do extraction. It's a really good video, and sometimes you just need to see a different point of view. So as you go down through here, I've included the directions that were also in the Lab 9 supplement that are online on Professor Sherlock's website. These are the directions you can read down through and figure out exactly how the process is done, and all the way down to here. Okay, the first thing that you're actually going to need to do and to look up is going to be information for this data table. Okay, so I need you to find the molar mass density, melting point, boiling point, and index of refraction of these three compounds. Not only do you need to find that information, those 15 pieces of information, if you used a source, I need you to indicate your source below here where it says sources. Okay, that's so that we know that you're getting things from reliable sources. Sometimes if you do a Google search for some of this stuff, it comes up and is kind of strange. So you probably want to use a better search than just Google to find it. But then it's up to you to answer these questions about the process and about the lab itself. So you're going to first write the reaction. Here's the thing, the supplement gives you the mechanism where it shows all the electrons pushing around. I don't want that. I just want to see the mechanism. So reactant yields product, or reactant arrow product. I don't need to see the whole mechanism for this. Okay, so I try to say that. Okay, and then so using the information in the balanced chemical equation and the data table, you should be able to determine how much cyclohexanol you would need if you're going to make cyclohexanone. So you want to have that in grams and milliliters. Okay, so you're going to assume 100% yield, and you're going to show your work. Okay, so it's going back to high school chemistry. Make sure you show your work. Okay. Also, the lab references this thing called glacial acetic acid as an initiator. I would love to know what glacial acetic acid is. Is it from Glacier National Park? Question mark? Little hint, spoiler alert, probably not. Okay, so since you're not going to be doing this lab live, I found this drawing of what the apparatus would look like, and we got there. Okay, this is the separatory funnel. So let me give you a little hint here. I asked you what the purpose of the separatory funnel is. The separatory funnel is not, I'll give you what it's not. It's not a marshmallow. I'm just kidding. I mean, it's not a marshmallow, but we want to know what it does do. But in this case, it's not. This is not part of the extraction. It's doing something in this apparatus, and it's not doing extraction here. It's doing something else. That's why I thought it was important to know that a separatory funnel can have multiple purposes in a lab. Okay, and then of course there's a thermometer here too, and we want to know why the thermometer is there. Okay, so like many things in organic chemistry, there's alternative ways to do stuff. So in your lab, you're using a starch and Ki solution, kind of like starch in a potato, like in BioLab, to find out starch test. It works also for the presence of the hypochlorite ion. Well, here is another version of that same test, okay? And the whole point is that it seems like the lab makes it a point to get rid of all the hypochlorous acid, which is also the hypochlorite ion. Same thing, okay? Synonymous in this case with each other. And so why do you think it's important to get rid of all of that? Okay, so then you extract. So this is going back to the process that there was videos on, and it says what's going to be present in the organic layer, and then why is distillation chosen as the final way to purify cyclohexanone. Okay, now I give you all the data that you would get from the lab. Here's an IR. It's a little tough to see, but you can still get the main peaks from there and what's going on. Okay, and then you get a GC. Notice the GC has 4 peaks. This is an air peak, peak 1. This is peak 2 at retention time 1.48. This is peak 3 here at retention time 4.08. And this is peak 4 here at retention time 7:03. Okay, so this is the bread and butter of this lab. So you've done the data, you've done the experiment. What I want you to do is explain, did you make pure cyclohexanol? Okay, so you want to use the details from the data to determine that. So and you want it to be a well-developed, well-written, at least 1 paragraph outlining this. Okay, so I give you a little bit of guidance there. I say use index of refraction and GC. Those two characterization methods can help you determine the purity of the compound. And then you can use IR and index of refraction to support the identification of the product. Is it actually cyclohexanone? Is it something else? Okay, and then the last thing that I want you to do is to comment on the percent yield. The percent yield for this lab is 55%. So you want to make sure you comment on, is that good? Is that bad? Why is it the way it is? Okay, does that reflect the actual yield? Is the compound, if the compound is pure, is 55% the actual yield? Is that a false percentage? Is it actually less? Is it actually greater than? Why is it low? Is it high? If it's high, why is it high? So I want you to provide all of these details as if you're writing up the lab yourself. Okay, so there you have it. It's a rather lengthy video explanation of this lab, but it's your first one of the semester, and I wanted to make sure that you had it. So make sure you do some good work, and have a great day, everybody. And if you have any questions, feel free to reach out.